Many people think strength is mainly about lifting weights or building muscle. But in biology, strength carries a much deeper meaning. Over the past few decades, researchers studying aging and health outcomes have noticed something surprisingly consistent. One simple physical measure repeatedly appears as a powerful predictor of long-term health: grip strength. It may seem almost too simple to matter, just squeezing a device with your hand. Yet study after study shows that grip strength is closely associated with survival, recovery from illness, and the ability to maintain independence later in life. This doesn't mean the hand itself determines longevity. What grip strength reflects is something much larger: the combined function of muscles, nerves, metabolism, and the brain working together. And when that system remains strong, the body maintains its ability to adapt. One of the most interesting findings in aging research is how strongly strength predicts health outcomes. Across large population studies, researchers have repeatedly observed that people with lower strength tend to experience higher rates of illness, disability, and earlier mortality. And one of the simplest ways scientists measure strength in these studies is grip strength. It may seem surprisingly basic, just squeezing a small device with the hand. Yet grip strength consistently appears as one of the clearest indicators of overall physical function. In many cases it predicts future health risks as well as, or even better than, several traditional clinical measurements. This doesn't mean the hand itself determines survival. What grip strength reveals is something deeper about the body's overall capacity. It reflects how well multiple systems are functioning together. Grip strength might seem like a measurement focused only on the hand. But in reality, it reflects something much broader about the body. Producing force requires several biological systems working together. Muscle tissue must be capable of generating force. The nervous system must coordinate and recruit those muscle fibers efficiently. Energy metabolism must supply the fuel needed for contraction. And the brain must organize and control the movement. When grip strength is low, it often signals that one or more of these systems is not functioning optimally. This is why researchers see grip strength as more than a measurement of hand power. It becomes a simple window into overall biological capacity. In many ways, it reflects how well the body's systems are working together. Muscle tissue plays a much larger role in health than most people realize. From a biological perspective, muscle is metabolically expensive to maintain. It requires energy, nutrients, hormonal support, and constant neurological coordination. Because of that cost, the body does not preserve muscle automatically. Instead, it preserves muscle when it receives signals that strength is still required. Those signals come through physical demand: lifting, carrying, pushing, pulling, stabilizing. When those signals are present, the body interprets strength as necessary for survival. And when something is necessary, biology tends to preserve it. This is one reason strength training has such a powerful influence on aging and health. Muscle is not just movement. It is a message the body receives about what capacities still matter. Biology is efficient. The body constantly adjusts itself to match the demands placed on it. When strength is used regularly, muscle fibers receive signals to maintain size, coordination, and metabolic activity. But when those signals become weaker or less frequent, the body begins to adapt in the opposite direction. Capacity that is not regularly used becomes harder for the body to justify maintaining. Muscle fibers shrink. Neuromuscular coordination becomes less efficient. Energy systems shift toward lower output. This process is not failure. It is adaptation. The body simply reorganizes itself around the level of demand it experiences most often. Over time, this is what many people interpret as aging. But in reality, much of what we call aging is the body responding to reduced stimulus. Strength is not only about muscle. Every movement the body performs is coordinated by the nervous system. When you produce force, the brain must recruit motor units, synchronize muscle fibers, and regulate stability across joints. This coordination is learned and reinforced through repetition. The nervous system becomes more efficient at supporting the demands it experiences regularly. But just like muscle, the nervous system also adapts when demand decreases. If movements become smaller, slower, or less challenging, the nervous system gradually reduces the level of coordination it maintains. Motor pathways become less active, reaction times slow, confidence in physical capability can also decline. In other words, the nervous system preserves the patterns it practices most often. Strength training is not only building muscle, it is also training the brain to maintain higher levels of physical capacity. StrengthSpan is a concept that helps describe how the body maintains physical capacity over time. Lifespan tells us how long someone lives, but it does not tell us how well the body continues to function during those years. StrengthSpan focuses on the preservation of abilities such as force production, stability, coordination, and movement. These abilities depend on the interaction of multiple systems, including muscles, the nervous system, metabolism, and the brain. When these systems remain active and challenged, the body continues to support them. When they are used less often, their capacity gradually declines. Strength therefore becomes more than a measure of muscle performance. It becomes a reflection of how well the body continues to adapt to the demands placed on it. In this way, strength can be viewed as a visible expression of the body's underlying capacity for adaptation. Researchers have looked for simple ways to measure this type of whole body capacity. One of the most consistent indicators that has emerged across many studies is grip strength. Grip strength is easy to measure, but it correlates with a surprising number of health outcomes. Lower grip strength has been associated with increased risk of cardiovascular disease, reduced mobility, greater disability, and higher mortality rates. These relationships have been observed across large populations and different age groups. The reason grip strength is so informative is that it reflects more than the hand itself. Producing force with the hand requires coordinated activity across muscles, nerves, and metabolic systems. Because of this integration, grip strength can reveal something about the overall resilience of the body. The myokinase released by contracting muscle interact with many different systems. Some influence metabolic regulation by helping the body manage glucose and energy balance. Others play a role in regulating inflammation or supporting immune function. Research also shows that certain myokinase can influence processes in the brain related to learning, memory, and neural health. This means that the simple act of contracting muscle during movement sends information throughout the body. In this sense, movement becomes a form of biological communication. Muscles are not only responding to the brain's commands, they are also sending information back into the system, influencing how the body regulates itself. Because of this, regular movement helps maintain communication between multiple systems that support overall health. Muscle tissue also performs an important function that extends beyond movement. In recent decades, scientists have discovered that muscle behaves as an endocrine organ. When muscles contract during activity, they release signaling molecules known as myokinase. These molecules are produced within muscle fibers and released into circulation during movement. Myokines act as messengers that allow muscles to communicate with other organs in the body. Through these chemical signals, muscle activity can influence metabolic processes, inflammatory responses, and even functions within the brain. This discovery has changed the way scientists think about muscle. Muscle is not only mechanical tissue responsible for producing movement, it is also part of a broader communication network within the body. The environment in which we live today is very different from the one in which human physiology originally developed. For most of human history, daily survival required frequent physical effort. Walking long distances, carrying loads, climbing, lifting, and building were common parts of everyday life. These repeated physical demands continuously reinforced the body's capacity for strength, coordination, and endurance. In modern environments, however, many of those demands have been replaced by convenience and automation. Transportation, technology, and labor-saving devices have dramatically reduced the amount of physical effort required in daily routines. When the body experiences fewer physical challenges, it gradually adapts to that lower level of demand. Over time, the systems that support strength and movement receive fewer signals that they are needed, and the body slowly adjusts its capacity accordingly. Adaptation is one of the most fundamental principles in biology. The body is constantly adjusting its structure and function based on the demands it experiences. When challenges increase, the body strengthens the systems required to meet those challenges. Muscles grow stronger, neural coordination improves, and metabolic systems adapt to support the additional effort. But adaptation does not only move in one direction. When demand decreases, the body gradually reduces the capacity that is no longer required. Muscles lose strength, coordination becomes less efficient, and overall physical capacity declines. Because of this, the level of strength and resilience we maintain is closely linked to the demands that are repeatedly placed on the body. Strength training represents one of the clearest ways to increase physical demand in a controlled and progressive way. When the body is asked to produce force against resistance, multiple systems must respond together. Muscles generate force, the nervous system coordinates movement, and metabolic systems provide the energy required to sustain the effort. Each repetition reinforces the coordination between these systems. Over time, the body adapts by improving its ability to produce force, stabilize joints, and control movement more efficiently. Through this process, strength training becomes more than a form of exercise. It becomes a stimulus that encourages the body to preserve and support the physical capacities required for movement, stability, and resilience. One of the most important things to understand about the human body is that adaptation never truly stops. Across the lifespan, the body continues adjusting to the demands it experiences most often. When strength is regularly challenged, the body maintains the systems that support it. In this sense, strength is more than muscle.